In today's world, it's becoming more and more common to store your data in the cloud. However, in the last year, ransomware cases have increased by 97%, and data breaches are now affecting millions annually. So, what can you do to fight back, and how do you prevent this from happening to you? Well, building on our previous dive into offsite data with Backblaze, we're going to be taking a look at more of the advanced configurations of the Cloud Sync task on TrueNAS. We're going to show you how to protect your data by using data immutability, remote encryption, and how to validate your restores. And don't worry, you can watch both videos in either order. I try and make them stand alone by themselves. Now, some of you might be wondering why it's important to actually encrypt and harden your backups. Well, first and foremost, it helps protect sensitive data if it falls into the wrong hands. So if a bad actor has access to where you're storing your data, he can't read what's on that data. So he can only have a copy of it and potentially try to decrypt it, which is why it's important to actually encrypt with a strong key. For other industries, it's actually a mandate by law and legal requirement using GDPR and HIPAA to actually encrypt your backups and store it responsibly so you have a insurance of data privacy and security. Failure to comply with these regulations actually results in a significant financial impact to the companies, such as 4% of their global revenue. Notably, when data breaches happen, such as the ones that LastPass experienced, it can be catastrophic for everyone around the world. This can lead to very sensitive information being exposed via passwords and logins for banking accounts or even secure notes about wills and lawyers that you're dealing with. When it comes to encrypting your data, there's really two choices: encrypt before sending or relying on your third party to encrypt your data at rest. Encrypting your data before you send it off gives you more control of your data security, while third party encryption services can simplify the process but require more trust in the provider's security measures. Ultimately, encrypting your backups in any fashion is a fundamental step in safeguarding your data and complying with legal and industry standards. So now that we know a little bit about encryption and why we would want to implement it, let's talk a little bit about immutability and why it's so important for your backup hardening strategy. Now, what is it? Immutability is a fundamental concept in a backup strategy. It refers to the state of data being unchangeable or tamper proof for a specific period of time. This means that once the data is written to a backup medium or a backup storage repository, you will not be able to modify, delete, or alter any of this data for a predetermined amount of time. Now, data immutability is very hard to implement unless you're leveraging a cloud partner or you have a very limited amount of files that you want to make immutable. The reason for this is because now you have to store every file and every version or revision of that file. The reason this is important, though, is because it allows you to safeguard against various threats like accidental data deletion, malicious attacks like ransomware, or even human error. By ensuring that backup data remains untouched for a predefined duration, organizations can maintain data integrity and recover critical information even in the face of unexpected challenges or ransomware attacks or data breaches. Some of you might be saying that isn't this just a read-only backup or a read-only repository? And while yes, it's similar, but it should not be confused with a immutable backup. The reason is that when it comes to immutability, administrators and users with the highest privileges are not allowed to modify or delete data during this certain period, right? With read only settings, on the other hand, they're allowed to change or modify or delete data, and that's just because they have permissions. Whereas immutability contains a locking mechanism that prevents everyone from modifying and deleting that data. Now, immutability can be implemented on any S3 compatible storage layer. For the following examples, we're going to be using Backblaze B2 cloud storage just to implement our object locks, which will allow us to demo the immutability aspect of our buckets. In the demo, we'll be creating a lifetime retention policy to make sure that the files in the bucket cannot be deleted and thus safeguard against losing any valuable data such as tax records or things of that nature. So let's quickly recap what we just covered. So if you don't have encrypt before send or you don't have your object lock in place, we have our backups going offsite, storing them in a Backblaze bucket, and then our bad actor that has unauthorized access can now read all of our data. So how do we fix this? Well, in TrueNAS, we can enable encrypt before send. This means that we're no longer relying on the Backblaze encryption methodology, and we're instead using our clone Crypt, which encrypts our data before we send it off to Backblaze. This means that our bad actor can no longer read all our data. So how do we prevent him from actually deleting this data? So right now, even if we do encrypt it before we send it, we are now allowing our bad actor to potentially delete, overwrite, or modify our data inside of Backblaze. Whereas if we enable our object lock methodology inside of Backblaze with a lifetime retention policy, they are no longer able to delete or modify our data that's there in our Backblaze bucket. This gives us a protection and a great restore point for our backups if there is an issue and an outage. So now that we know what we're dealing with, let's dive into TrueNAS and Backblaze to implement some of these settings and harden our backups along with our APIs. So let's briefly go over what we did in the last video. In TrueNAS, we configured a share that allows us to upload files easily for our demo. We also created a set of a backup credential that is pointed to our Backblaze East account. And we also created a cloud sync task that uses those credentials to upload to Backblaze. Inside of Backblaze, we created our credentials and also created our bucket that allows us to store our data on Backblaze itself. However, as noted earlier, our data is not encrypted here, so we're actually trusting the Backblaze encryption, which we do not have enabled for this account. So now let's take a look at how we can enable TrueNAS encryption before we send our data off to Backblaze. So coming into our Cloud Sync task, we are going to double click on our Backblaze B2 East backup, and we're going to scroll here to the bottom for remote encryption. This will allow us to enter an encryption password and a salt. And I'm not going to dive too deep into this, but I'm going to set a super secure password of password123. And we're also going to add a salt of Dead Sea. So as you can see here, we can add our password and our salt. And then we're just going to click save. And then we're going to run our backup again. And that it's completed, we're going to take a look at our files, hit this refresh button, and show that it's actually been backed up and stored into Backblaze as an encrypted file. So now after downloading the file and opening it up, we're able to see that the file is not readable by us, and we don't know what's actually stored inside of this data. You can see that it's actually encrypted by our clone, but that's about it. So now that we have our encrypted data stored up here, we can delete the demo file that we uploaded originally. We can simulate a failure by actually deleting this file and attempting to restore back to our source repository here. So in order to restore, we're going to hit this restore button here, and we're going to say our YouTube demo is our description. We're going to save it in copy point, and then we're going to put it to our directory where we have the SMB share for our YouTube demo. So we're going to now hit restore. We can see that we have a new task here, and it's in a pending state with a disabled for the next run. We're going to hit run now. And now that it's completed, we're able to see that we have our data back on our SMB share and that our file is actually readable to us again. So we have our super secret stuff file restored back onto our SMB share. So now one quick note about the encryption password and the salt that we have configured inside of our Cloud Sync task is that we want to make sure we actually have these backed up somewhere. Now, we also want to make sure that we're actually using a proper password and salt, and that we're not using some commonly used password. We actually want to use a password generation tool that we can make sure that it's not easily attainable by a bad actor. So this is stored in one location by default. However, you want to make sure that you actually store this in a password manager or print it out and store it in a offsite location to make sure that if there is an issue, you still have access to the password and you are not compromised in a way that you cannot recover your data. Now, by default, this is automatically stored into the TrueNAS backup and will be recoverable that way. However, you need to make sure you have a good backup of that as well. So now that we know how to encrypt our data before we send it off to Backblaze, let's take a look at how we can make our data immutable. So inside of Backblaze, we're going to create a new bucket that allows us to enable our data immutability. And as you can see, I was playing around with it here prior to recording this video. So inside of our new bucket creation, we have to create a new bucket. test locking YouTube demo, and we are going to enable object lock here, right? This will allow us to enable data immutability with our object lock retention and our lifecycle policies once we have it enabled. So we're going to go ahead and create this bucket. And now inside of our bucket here, we're going to go to the lifecycle settings and make sure that we have this all enabled the way we want. And then we want to go to our object locked. And inside of this object lock policy, we want to set how long we want to keep these files for. So in my case, we're going to set this to 3. This way I can delete them after 3 days. So now a quick note about this is if you do not have this policy enabled for your bucket, you can still have your object lock settings enabled. However, no files inside of the bucket will be locked automatically. This will mean that you can lock files manually. However, it will not be set automatically by the lifecycle policies of the bucket. And this can be crucial for your applications that need this setting by default. So it's important to come in here and make sure that you actually validate that you have a default retention policy set for your bucket, and then just hit save changes. So now that we have this configured, we'll want to make sure that we have another API key that writes directly to this bucket. So under application keys, we're going to create a test locking YouTube demo key, which will only have access to our test locking YouTube demo, and we can allow it to list all our buckets. So let's go ahead and create a key. And remember that these key IDs are available when viewing the keys. However, this application key will need to be regenerated if you ever lose this. So we're going to go ahead and copy this to clipboard. And we're going to go back to TrueNAS and add in our backup credentials. And we're going to create a new set of credentials for our backup storage here. So now we're going to find Backblaze. We're going to find Backblaze. And we're going to select our locking bucket. And we're going to put in our application key and then our key ID. We're going to hit verify to make sure that we can actually connect and the credentials are valid. And then we're going to hit save. So now that we have our credentials created, we can actually go back to our data protection and then create a new Cloud Sync task. So inside of this Cloud Sync task, I'm going to name it the same as our demo bucket name and along with our credentials for our application key. We're going to select our new Backblaze application locking key, and we're going to create a push policy that connects to our test locking YouTube demo bucket. We're going to say that we want to back up this data into the root of that bucket. And then for demo purposes, because I do not want to have another fully locked version of my backup stored somewhere for 3 days, I'm going to limit what I actually have pushed up. So inside here, I'm going to select only the YouTube demo SMB share that we have for our file explorer that we showed off earlier. So scrolling down to the bottom, we're also going to enable remote encryption. So now I'm not going to modify this cron job since I'm going to be kicking it off manually and I'm not going to leave this job around. But in the past video, we actually modified it so that it would back up every other day for every month of the year. So now we're going to hit save. So now that we have this job created, we're going to hit the run now button, which will kick off this job and hopefully it'll finish fairly quickly. And then once it's finished, we can see inside of our locking demo that we have a file that got created here. So if you actually open up this file, you'll see that you have a compliance mode that's enabled and expires on a future date. This will mean that you can't delete this file. So if we go ahead and close this file and attempt to delete it, you'll see that you have this option that'll say, okay, well, some of the files you selected are actually on a legal hold or held for retention policies. So even if you hit this delete button, this file will still remain in your bucket. So now if we want to, again, delete this file out of our SMB share here, let's go ahead and delete this. And yes, this is fine. We're going to attempt to restore from this exact locking bucket. And we can see that we can actually restore this using a locking restore as the name. And we're going to use a copy mode. And we're going to restore it to the same location that we have our SMB share for our YouTube demo. So now we hit restore. And we see that we have a misspelled locking restore button. But we're going to hit run now. So now that it completed, we could see inside of our YouTube demo bucket that we can see our file has returned again, and we're able to access this data. So one more thing that's important to talk about when you talk about doing these restores and testing to make sure that your encryption works is one, making sure that you have those passwords and the salts backed up somewhere, and also making sure that you can actually do a test restore for all of your data every once in a while. Now, I know this can be expensive and can be difficult to do if you have a smaller system, but it's very important to actually understand your run book when you actually have a disaster. This way, you can make sure that all of your files are restored locally and you won't have any issues with recovering things in the future. So, now before I sign off, I just want to state again the importance of having a backup encryption and data immutability practice in place for your backup procedures. And remember, the saying goes that your data is only good as your last backup, and your backup is only as good as your ability to restore it. For a deeper dive, don't forget to check out the articles I linked below for each topic discussed. And if you found this video helpful, you'll definitely want to check out the other video on TrueNAS and why I highly recommend Backblaze for your backup solutions. If you have any experiences to share or feel I've missed any topics, please leave a comment below, and I will either address them in the comments or in a future video. And as always, thank you very much for watching.